All right, hello everyone, and welcome to the October-November 2020 PRM for the variant 2.1. Today, in this video, we will be discussing the actual requirements as per the question, what the program is going to be about, understanding the program, and then going through the emulator, which is the final the outcome of the program that we are going to write. In the following videos, we will be discussing the actual pseudocode and how to write it, and going through it, understanding what part means what, and how you can write it for yourself. But in today's video, we will be focusing on the actual requirements. We will be understanding the question. We will be looking through all of the details and making sure that we understand what we are required to do before we actually do it. So, without further ado, let's get started. So let's read through the question paper, and I will explain what each part means, and then we'll also run through the final program. So it says that your preparation for the examination should include attempting the following practical tasks by writing and testing a program or programs. We shall be doing that. A car insurance system allows, so this is the actual question now. A car insurance system allows customers to check how much it would cost to buy a car insurance, to buy insurance for a car for 12 months. The starting price of the car insurance is $500. So this point is something important, and we'll be coming back to this within the code and everywhere. So keep this one in mind. The actual price a customer pays for the car insurance changes depending upon this information: the engine size of the car, the value of the car, where the car is kept overnight, the number of kilometers driven a year, the age of the driver, and the years insured without an insurance claim. Okay, so first things first. We need to understand the perspective of this year's question. So we are pretending to be a car insurance company where the program we're writing is one of those programs that allows a customer, a potential customer, to calculate how much their car would cost them to be insured. And so like any really like any form, there are a number of parameters, or there's a number of fields which determine what the value is going to be, and it changes according to that. Similarly, here we have all of these factors which will impact the actual price of the car. Moving forward, the actual price is calculated by finding the total of the percentage changes for the customer using table 1. So we will be using this table to find the total percentage change in the price. So the way that's going to work is, for example, let's say that when we ask the customer what the engine size in liters is, they say it is 1.5 liters, right? So 1.5 liter comes within this range, which says greater than 1 to 2.5. So what that means is greater than 1 and less than equals to 2.5. And so since 1.5 is within this range, the price change from here is going to be plus 5%. Now let's say that we move on, and we ask them what the value of the car is in thousands, and they say it costs $5,000. So 5,000 comes in this range, which is 2 to 10,000. So here it says value in thousands. So the fact that this says 2 doesn't mean it's $2, it means it's $2,000. This is in multiples of thousands. So 2 to 10 means greater than 2 to 10 means greater than 2,000, or less than equals to 10,000. So let's say that somebody says that the value of their car is $5,000, so it comes within this range, and so the price change for this particular factor is plus 5%. So up till now, the total price change has become 5% plus 5%, which is 10%. So and so forth and so on for all of these other factors, and that's how we will be calculating the actual percentage change in the price of their car. So then we will be applying this total percentage change to the starting price of the car insurance, um, which is right here. So remember how I said we'll be coming back to this. So every percentage price change that we will apply will be applied to this amount, which is $500. So whatever we add or subtract, depending on what the total percentage change turns out to be, it will be done on to $500. And as we go through the code, how that's going to be done will make a lot more sense, but that's for a later video. So applying the years, so next we have to apply the years without claim discount percentage for the customer using table 2. So once we have calculated the the total price using table 1 and the starting price of $500, that price will then be discounted by looking at this table. So this table basically says that if, for example, a customer has had an insurance on a car for 5 years and they have not claimed that insurance, then the discount for them for 5 years for 5 years without claim is negative 50%. So whatever the total price of the car came out to be, we're going to reduce that by 50%, and so that's the years without claim discount. So next it says that write and test a program or programs to calculate the price for a customer to insure a car, which is exactly what we will be doing. Your program or programs must include appropriate prompts for the entry of data, and data must be validated on entry. So we'll be covering this in a lot more detail in the following videos, but just for a brief overview, what this means to have appropriate prompts for the entry of data is that a prompt is basically the statement or the line of code or the line of text that comes out when we want someone to enter data. So the user, so if I say enter your name, and then there's a place where they can enter the name, that enter your name string, that is the prompt. And so data must be validated on entry. That just makes sure that, for example, if we're entering the engine size in liters, whatever data we have entered is fits within the allowed range in here. So we will be doing that as well. Error messages and other output need to be set out clearly and understandably. So, for example, if the data validation does not show that the data is correct, then the error message that we send needs to be set out clearly, and they must understand what the error is. So all variables, constants, and other identifiers must have meaningful names. So, for example, if we are storing the engine size that the customer has entered, we can't just say that it is parameter A. It has to be engine size liter, whatever. But it has to be something that that someone who's going through the code, who has not written the code, or even for that matter the programmer, later in, like, after 2 or 3 months, when they go back through the code, they should be able to understand what each variable is doing, instead of having to dry run through it and see what variable changes according to what. So every variable, constant, or any identifier we use, so the identifier is just the name given to a constant or variable. So whatever identifier we use must be relevant and must relate to how to the values it's storing. Okay, so throughout the pseudocode, throughout the PRM, we will be completing these three tasks. Each task must be fully tested. So task one is to calculate the price to insure a car. So it says that we have to write a program to obtain the required information from a customer and calculate the price to insure the car. So basically, what we will be doing is we'll be giving a lot of prompts, and then we'll be taking in these values, and then we're going to check which range the value lies in, and whatever range that is, we will be updating the price change to by the corresponding values. So display next we have to display the price to insure the car. So whatever the total price turns out to be after all the percentage changes have been applied, we will be displaying that, or in other words, we will output that. Display the total percentage change calculated from table 1 and the years without claim discount percentage from table 2 separately. So what we will be doing is that once we are outputting the total price, along with that we will also be displaying the actual percentage change that was accumulated through all of these. So after we have gone through this entire table within the code, whatever the final percentage price change was, we will be displaying that hey, this is the percentage change that we applied. um, and the years without claim discount separately. So whatever, however many years it had been for that particular customer without a claim on their insurance, we will also be showing that this is the discount he or she received. So, and that's task one. Now task two is the new customer discount. So in task 2, we will be extending task 1 to include an additional discount of 10% of the price to any new customer who is aged between 26 and 70 inclusive, who also has 2 or more years without a claim, and then we also have to display the amount of money this would save and the new price. So three things that are happening here. One, we are going to check whether uh, whether there is a customer, or rather when the customer has done entering all the data required for task 1. We will also be asking them, or rather from the information that they have already given, we will judge if the age was between 26 and 70 inclusive. So what this means is 26, 27, all the way up to 70, and we are including 70, and we are including 26. So everything between 26 and 70, including 26 and 70. So that's what inclusive means. And if the years without a claim that we ask them to input in task 1, if that turns out to be more than 2 years, then we will apply a additional discount of 10% on the price that we already calculated. And then we also have to display the amount of money that has been saved by this discount, and we also have to show them what the new price of their insurance is. So that's task 2. And then finally, task 3 is adding an extra driver. So the customers can add one extra driver. The age of the extra driver may increase the price. The new price is calculated by applying the percentage change price for the age of the extra driver from table 1 to the price. And then we have to extend task 2 to calculate and display the new price, including an extra driver if required. So what's happening here is that we once we're done with all of the other tasks, between the tasks we will add another code where we ask the customer if they wish to enter another to add another driver, and if they say yes we do, then we have to ask the age of the new driver, and whatever the age is, depending on the exact same factors that we used to calculate the initial age in task 1, we will apply that factor once again, and there's going to be a new change in price, which will be impacted depending on the age of the new driver. And so after that we are done with all three tasks. So the way we are going to run through the program is that the pseudocode that has been written is a unanimous pseudocode. So there's no separate files for task 1, task 2, task 3. However, it has been clearly identified where task 2 begins and ends, which parts are necessary if you're asked only to write the pseudocode for task 1, which parts you have to write if you have to write task 2, and which parts you have to write if you have to write task 3. So there's no discrepancy between which block of code belongs to which task. However, there is you don't have to write the code for task 2 and task 3 if you have only been asked to do task 1. So for the second part of this video, let's run through the emulator, which is the outcome of what this code will look like once it's done. So here, once you load it up, this is the first thing that appears, and so this is the prompt that we talked about earlier. So the enter the engine size in liter of fuel. This is the prompt that has been given. So let's say I say it is 1.5 liters. So I enter 1.5. So now what the program has done in the background is that it has checked this value that I have entered. It has checked that against this table, the conditions that have been set according to this table, which we'll be discussing in a lot more detail when we actually go through the code. It has checked against all of these ranges, and whichever range my value fitted in, it has applied a price change. It has memorized or stored in memory the price change percentage for that particular factor. So next, it has asked me to enter the value of the car in thousands. So once it's done with this part of the table, it moves on to this part, and where if I say it is 5,000. So if I want to write 5,000, I'm going to write it like that because the value of the car is in thousands. So 5 means actually 5,000. So once I enter that, it has done the exact same thing again for this table. So it has seen which range it lies in, and it has updated the price change according to that. So next, it asks me where the car is kept overnight, whether it is in the garage, it is in the street, or it's in the drive. So I have one of these three options. So for now, let's just say I put it in the drive, and it also tells me that what are the valid options that I can enter. So I'm entering drive. I'm entering drive. Next, it asks me to enter the kilometers driven per year in thousands. So now we're moving on to this table. To enter the, let's say I drive 8,000 kilometers a year. So and now it asks me to enter the age of the driver. Let's say I'm 21. I am not, but let's just say that. Enter the number of years without an insurance claim. So now it has moved on to this table. Let's say it has been 2 years. Would you like to add another driver? Now this is the this is the in action, the pseudocode that or the part of the program, the code which is working for task 3. So task 3 is the add another driver part, and I say yes, I do want to add another driver. So now I want to enter the age of the second driver. Let's say 23. And so now it outputs all the data from all three of the tasks. So let's go through them. So it says that the total percentage change in the base price of insurance is 110%, which is the requirement of here. So task one, it says display the total percentage change from task one. However, the total percentage change will also be updated depending on the price of the price, right? The age of the new driver. So whatever we have calculated from task one, we will update that with the percentage from task 3. Then it says the percentage discount due to the years without claim is 20%. So that is this part of the code in action. So display the years without claim discount percentage from table 2 separately. So that's this part. Once we go through that, it says the amount of money saved by applying the new customer discount. So that is task 2. So it says display the amount of money this would save. So in the background, once we entered all of this, what it actually did is that it calculated all of these values, which we will be going through when we go through the code. But as the customer, you won't actually see what's happening in the background. You're just going to get the information. So that's what the emulator is. Is that this is this is how the code will look to whoever is on the other side of the program, on the front side, I mean. So the amount of money saved by yeah, okay. So the price to insure your car is $640, which is the final price that we have to display. So display the price to insure the car. It should be noted that the price to insure the car has been updated by all by the two other tasks as well. So when you're writing task one, you will just omit the part of the program which codes for task two and task three, but you will still be displaying the price of the car. So all the other things will still be there. It's just that the intermediate code for task 2 and task 3 will no longer be there. So that is, let's just exit out of this. So that is how our PRM for this year is going to look. That is what we are required to do, and that is the final outcome. That's what the program should look like. And so in the following videos, we will be discussing the actual code. So this was the front end. Now we will be discussing the back end, the actual programming, um, how the program is going to go about, what statements we're going to be using, what loops we'll be using, how we will be coding for task one, task two, and task three. Yeah, that brings us to an end for this video. The explanation part is done, and I will see you next time when we discuss the actual code.